Hello Squirrels, welcome to the Squirrel Game Dev. Today we'll deep into actual gaming stuff and I will show you how to make a jumping squirrel. We begin with some theory, but like in any game it's fundamental. I can swear I won't hurt you much. I'm just kidding, it's easy. So first, if we want to make our squirrel jump, we should know what actually the jumping is. Let's think about it. I mark our squirrel on the chart as a yellow ball to simplify it. When we jump, our legs need to give us some initial force that can push us up in the air. Then, because the force is quite big, the movement begins sharply, but it means it quickly loses a lot of our speed due to the gravity, and at some point we steadily lose all of it and we stop in the air. Then, as expected, we start falling down the same way but reversed. So that's quite intuitive, but let's think about it in a physics way. We already said that this movement isn't steady all of the time. It begins sharply and ends with some easing, which means it has some acceleration. Such movement, which bases on acceleration, is called uniformly variable. It divides into two types: accelerated and decelerated. Accelerated describes a movement where we don't actually have any speed in the beginning and we gain it with acceleration in the future. So that's not what we actually want. Today we will look at the uniformly decelerated motion, which, as I have shown you on this chart, is exactly what we thought of. As we see it right here, it is the shape of a parabola. What it means is it goes to infinity. That's actually good, because if we didn't have any ground underneath us, we will continue to fall forever with more and more speed. So next we want to think about this problem in programming way. We need a pattern that can describe a decelerated motion, which we can use to generate the next frames of our jump. That's how a formula for the uniformly decelerated motion looks like. If it looks scary, don't worry, I will explain it to you. Let's look at the variables describing this formula. We've got an x0, which means the initial position of our object, t, which is a time delta. Each loop iteration takes some time. A delta is an accumulated time measured from the motion start to the recent frame render. The next thing can be confusing. A is equal to Z. Well, because it's just a game. Not the real world, we don't have here an actual mass, force, pressure. Even we measure the distance in pixels, not in the standard measurement units. It's difficult to calculate our acceleration then. The best way to do that is just by looking at how our object behaves. That's why there is a Z. And we're left with the initial velocity. There is no common initial velocity formula, but we can calculate it from the formula for acceleration. It's the absolute value of the final velocity minus initial by the maximal time, which is the time it makes our squirrel to move from its initial position to a maximal point of the jump. After then we can get rid of the final velocity because it's just zero. So after all, we've got the formula for acceleration, which is the initial velocity by maximal time. Then we can rearrange it and we've got our formula for initial velocity. We have everything needed to use our decelerated motion formula. We can only simplify it a bit and we stay with the current x position is equal to initial x plus time delta times, in brackets, doubled initial velocity minus acceleration times time delta, all this divided by 2. So finally we've got it. Let's write it then. So I began with a simple C++ code to check if it works. All of our formulas are implemented there and I used a for loop to simulate a time delta. After compilation, you can actually see that it works. We see that the highest point is exactly at the maximal time. we can manipulate height and speed by changing Tmax and acceleration variables. Okay, that's enough of the theory. We need to make our jumping squirrel. But before we start, I want you to know that all of the code that is written by me is available on the CodeSandox. If you want to test it, just visit a link in the description. Moreover, we will use this platform to code games on the live streams. So if you are interested, subscribe to this channel to not miss any hot info. So we are in a new project. We begin with creating a jumping squirrel, later we will create textures for it, so it will look like a squirrel. As we want this animation to be frame by frame, we'll use canvas to do it. So we use a canvas tag where we specify its width and height, and then call a react use effect function, which inside will be interpreted after our component mounts. We'll call a drawing function here. I make a reference to our canvas with an use ref, so I can easily manipulate it and draw inside. After then, I do some CSS to make our canvas look prettier. And finally, our rendering function. Inside we clear all its previous content, loop it, so now it can render further frames and calculate the time delta. As the CodeSandox has a hot preview, I made a function cleaning the browser from the previous live updates. Now my computer won't explode from an excess of infinite loops. Then the squirrel class. Its object will contain all of our squirrels data like width, height, and XY positions and jump offset. Finally, we draw our square. Then I create an accumulator called C. It will keep a jump execution time and will be reset back to 0 every time a jump ends. As we've got all data needed to calculate this jump, implement our formula. It works great and it looks like it was literally jumping, but it jumps infinitely. The next step is to make this square jump on a key press. I picked a double key. I made 3 states of the key pressing. P, which means it's pressed, A, activated, which ensures that its action was executed once, R, just a release action. The main idea is to make our object jump once when the key has been pressed and released before it lands on the ground, and multiple times when it's still held. So we have the middle step done. Now we need to replace a square with a squirrel. But how? We cannot just play a movie animation. What if we decide to extend the jump or change a game scale? It's so inflexible. The best way is to divide our game into equal parts and assign each of them their own keyframe. So I drew an animation using Adobe Animate. It's a jumping squirrel making a salto in exactly 21 frames. We need to export it in the PNG sequence. To do that correctly, we need to ensure that it doesn't stick out of the artboard in any frame and it has one common center. In this case, it's the middle of the squirrel's belly. When we play it, it just seems to spin around. Anyway, back to the code. After importing all of the frames, we are able to use them in our canvas. As all of them have incremented names, we can import them using a for loop and push into an array. In the next loop, we want to calculate which frame should be displayed in this loop iteration. We simply divide our jump into 21 pieces and try to calculate which of them we can assign to this particular frame. So if animation is 7% completed, we know we should render the second frame of animation. Then we see it actually jumps. It looks pretty, doesn't it? In the next step, we calculate hitboxes, which we assign to our object. Hitbox is a rectangle, which, if any object intersects, our game will treat it as an interaction. Here we are. So the last thing we need to do is to make it customizable for you. I'm going to do some inputs so we could check on your own how the jump will look like when we change acceleration or maximal time. You can enable there auto jump and hitboxes too. I hope you'll have a fantastic time playing with it. As you can see there, changing these two parameters actually works. And as I said, it's better to do it just by looking at its behavior. You can visit this page and try to get the best parameters for your game. I'm not actually sure if there is no formula to calculate them using a distance you want to launch your character on. If you have any ideas in your mind, just share them in the comments with other squirrels. That's all for this video. If you got to this point, it means you will for sure like my future videos. So please subscribe to this channel. It's 100% free and you'll be informed about all of this crazy stuff I'm planning for you. So you know what to do. See you in the future videos. Bye!